For this lesson, we're going to look at how we can use sine law and cosine law when the angles that we're given are obtuse angles. So obtuse angles are angles that are, here I'll move that down, sorry, angles between 90 degrees and 180 degrees in size. So I don't know if you've noticed, all of the questions that you've had so far in these lessons, all of your independent practice have dealt with acute angles. So all of the angles that you've solved for or that you've been given, maybe you've been given some obtuse angles, but any angle that you've been asked to solve for has been an acute angle. So it's given you an angle size. Your calculator has given you an angle size less than 90 degrees. So what happens when the angle that you're working with is actually larger than 90 degrees? So, you know, an example might be if I give you a big fat triangle kind of like that, and I ask you to solve for this angle here, okay? Hopefully you can see that this angle, theta, is much larger than 90 degrees. 90-degree angles make a square, right? They're the corner of your paper here. And we know that this angle is definitely bigger than that 90 degrees. You know, if you put a corner of your paper here, you could still see a big chunk of that angle poking out on the other side. So is this a big deal? Like, do we have to worry about angles that are obtuse now? Well, it depends. It depends what we're doing. So that's what this table here is intended to show you. So I've given you some examples, and I'll just show you where these numbers have come from. So I'm going to make sure my calculator is in degree mode, and I'm just going to press sine of 110 degrees in, and I'm just going to write the first 4 decimal places. I'm going to round it, so 0.9397 is the sine ratio for 110 degrees. Then I'm going to try exactly the same thing for cos. Cos ratio is negative 0.3420. The tan ratio is negative 2.7475, if I round it carefully, right? Because right after this 4 here is a 7, so I need to round this 4 up to a 5. Okay, and this column is maybe a little bit weird, but it's just saying, hey, take 180 and subtract theta. So this is our list of theta. So 180 subtract 110 is 70 degrees. And I guess I should put that here. Okay, so, and now what we want to do is we want to take the sine, cosine, and tangent of each of these new angles of 70 degrees. So pause the video, do this work, and then let me see what you, and then kind of I'll reveal what I get, and then we can compare those. Which means that the obtuse are negative. So it means that if we get a cosine ratio that's negative and a tangent ratio that's negative, then we are dealing with an angle that's greater than 90 degrees. Well, we don't really have to worry about tan because we don't have tan law. We don't need tan law. We can solve for every angle and every side in a triangle with just sine and cosine law. Okay, so really we just need to worry about sine and cos. Now, this may be very interesting to notice that, you know, negative cosine ratios give you obtuse angles, but you don't really have to pay too much attention to that because our calculator can tell us that. When we have a negative cosine ratio, when we did cosine law, you would get an angle greater than 90 degrees, and that would be your answer, and that would be it. It would be done. Well, what this means for us, really, that we have to worry about is when we use sine law. Sine law for acute angles, or sorry, the sine ratio for acute angles and obtuse angles is exactly the same. Okay, so if I'm solving if I'm solving for a sine of, let's say, sine of 60 degrees, right? Let's say I have this ratio of 0.8660. So I'm using sine law, and I've got 0.8660. That's my sine ratio, and I'm trying to figure out what angle size that is. My calculator is going to tell me it's 60 degrees, right? But what if the angle is obtuse? What if it's actually 120 degrees? Well, your calculator will never tell you that. Your calculator will never give you an obtuse angle for sine, okay? And it will for cosine, because a cosine ratio could be negative. So if you give your calculator a negative cosine ratio, it will give you an obtuse angle. But your calculator will not do that for sine. So what we're going to need to do is we're going to need to kind of go to the bottom of our page and note this really important paragraph here. If we use the sine ratio in our calculator, we're never going to get an angle larger than 90 degrees. If we use sine law, but we know that the angle is obtuse, and the way we're going to know it is from the picture, right? Think about this picture that I drew up here. This angle clearly is obtuse. It is clearly bigger than 90 degrees. So if I give you a picture of a triangle and you're solving for what looks exactly like an obtuse angle, then you're going to have to do an extra step. Or what happens also sometimes is that we're told that in a question. And I've been trying to get you guys to read questions carefully, and this is another exactly good reason why we need to read questions carefully, because it might just be kind of tucked in that question, you know, solve for the obtuse angle theta. And you just see a picture and you just solve for theta, and you never stop and you read the question. So we want to be really careful. How do we know what the answer is going to be? Well, we must find the supplementary angle. So it's going to be 180 degrees minus whatever we get for theta. And that will be our answer. That's our obtuse angle. Okay, I want to just, one more thing. Students often have some troubles with the first question in the independent practice. So I just kind of want to talk about it for a second. Are the following equations valid? So that just means, is it true? Are they true? Now, you can totally throw this in your calculator. You can do sine of 25 and sine of 65 and check if they're exactly the same. And that's not what I want you to do. What I want you to do instead is I want you to think about what we just learned from the lesson here, right? So will a sine ratio for 25 degrees be the same as a sine ratio of 65 degrees? Well, let's think about why 25 and 65. Well, 25 plus 65 equals 90 degrees. Did we do anything with 90-degree complementary angles? No, we didn't. Okay, so what other ratio would sine 25 be equal to? Well, sine, and this isn't part of the question, but I think it kind of helps you answer the other questions. Sine of 25 is going to equal the sine of 180 minus 25. Right? So sine of 25 is going to equal the sine of 155 degrees. And I'm just going to get my calculator out and just double check. Sine of 25 is 0.4226, and sine of 155 is 0.4226. Okay? So because the sine ratio for supplementary angles is exactly the same. So how does that help us with B? Cos of 70 equals negative cos of 110. So go back to the table on the previous page and see how this kind of plays out. Does this make sense? Okay, and I hope that kind of helps you. It's kind of a small little add-on to sine law and cosine law to think about what happens with obtuse angles. But it is really interesting math. So I hope it makes sense, and you guys have a couple of days to work through some independent practice on this. Good luck.